Hello class, and welcome to today's algebra lesson, which is about solving absolute value inequalities. By the end of today's lesson, you will be able to solve inequalities that involve absolute values. When we solve inequalities with absolute values, there's going to be a couple different scenarios that we are going to encounter. The first scenario is if it is an AND statement. It's going to be an AND statement if the symbol is less than or equal to. This is talking about, once again, if something is between, or you might hear the phrase inclusively. So that's saying that our answers are within a specific range. If you are under that first case, that AND type, you still have to solve case 1 and case 2. So just like when we were solving absolute value equations, the first case was the positive, the second case was the negative. We still have to do that with absolute value inequalities. The first case is the positive, the inequality sign stays the same. The second case is the negative, and when you flip it to the negative number, you have to flip the inequality sign. The second type is the OR. That's if you have the greater than or equal to. That's going to be something that is outside of a specific range, or the variance is more than a given value. Once again, if you're in that OR type, you still have case 1 and case 2. Case 1 being the positive, keeping the inequality the same. Case 2 being the negative, flipping that inequality sign. So we're going to start with just some very basic ones to look at what this means on the graph. When I have the absolute value is less than 5, the first statement here is going to say x is less than 5. So if I put that on the graph, I would go over 1, 2, 3, 4, 5, open circle, and moving to the left because we want it to be the values that are smaller. Then for case 2, I would say x, flip the inequality sign to a greater than, and then change it to negative 5. Now this would go over to negative 1, 2, 3, 4, 5, and then it's getting bigger now. So this is, once again, one of those AND cases where it's between those values. So you can see on the graph, when we have the less than, it's going to end up between those two numbers that we have. Moving on to the greater than case, if I have my first statement, it's going to be x is greater than or equal to 5. So I go over to 1, 2, 3, 4, 5. In this case, it's a filled in dot. And then it says greater than, so that is moving to the right. With case 2 then, it's still x, flip that inequality sign to less than, and change it to a negative 5. So I go negative 1, 2, 3, 4, and 5. Put once again my filled in dot, my closed dot, and then these ones are moving to the left. So you can see that this greater than statement is going to give me the OR case, where they are moving outside of that given range. So the less than or equal to, this is the AND scenario where it's between. The greater than or equal to are the OR scenario. Now we're going to do a couple examples where we have a little bit more complex problem. So I've got the absolute value of 2n minus 18 is less than or equal to 2. First thing we want to identify is that this is less than or equal to, so it's going to be an AND statement. Then I'm going to break it into case 1 and case 2. So 2n minus 18 is less than 2 is going to be case 1. And then the same part, 2n minus 18 is greater than or equal to negative 2 for that second case. Then we're going to go ahead and solve both. So the first thing we're going to do is add 18 to both sides. And that's going to give me 2n is less than or equal to 20. And dividing by 2 on both sides, I get n is less than or equal to 10. When I come over and solve the one on the right, so this case 2, once again, I'm going to add 18 to both sides. And that's going to give me 2n is greater than or equal to 16. Dividing by 2 on both sides, I get n is greater than or equal to 8. So my statement now says n is less than or equal to 10, and n is greater than or equal to 8. So if you write that as one compound inequality, it's 8 is less than or equal to n, which is less than or equal to 10. So I'm going to put my 2 dots on my graph, and because it is an and statement, those answers are in between. An example of an or statement. We've got a greater than, so we know that it's or. Once again, we take it and break it down into case 1, which in this case is 3x plus 3 is greater than 18, or case 2, which is 3x plus 3 is less than negative 18. Once again, we are going to start by solving case 1. Subtracting 3 on both sides gives me 3x is greater than 15. Dividing by 3 on both sides of that inequality, I end up with x is greater than 5. When I move on to solve case 2, once again, start by subtracting 3 on both sides. So I have 3x is less than negative 21. Dividing by 3 on both sides of the inequality gives me x is less than negative 7. So now my final answer says x is greater than 5 or x is less than negative 7. So because it's an or statement, we have the 2 separate pieces to graph. First, we go over 1, 2, 3, 4, 5, open dot, and it is getting bigger, so it is moving to the right. And then with your second one, negative 1, 2, 3, 4, 5, 6, and 7, once again, open dot, it is less than, so we are moving to the left. Go ahead and try this one on your own. First, I want you to tell me, is it an and or an or statement? It's an or statement because I have greater than as my inequality sign. Go ahead and solve case 1 and case 2. When you solve case 1 and case 2, I've got y is greater than 3 or y is less than or equal to negative 4. Now I want you to tell me the dot and the direction for both of these inequalities. For case 1, it is a closed dot moving to the right. For case 2, it is a closed dot moving to the left. There are a couple special scenarios when we have these absolute value inequality statements. Remember, absolute values are always positive. So what this first one is saying is that a positive value is less than a negative value. We all know that positives are not less than negatives. So if you ever see a statement that says an absolute value is less than or equal to a negative, this is going to be a no solutions scenario. So if it's less than, it is a no solution problem. If we flip down to the other case where it's greater than, this says a positive value is greater than a negative value. We know that all positives are bigger than all negatives. So if it is greater than or equal to with an absolute value compared to a negative, this is going to be the all solutions scenario. Any number you plug in is going to work. So once again, if it's comparing the absolute value to a negative number, it's either going to be no solutions in the less than or equal to case, or all solutions in the greater than or equal to case. So here's just one more time that recap. If it's greater than, it is all solutions. If it is less than, it is no solutions. Word problem here. We've got a debate team is traveling to a tournament and will spend 4 nights in a hotel. The cost of each team member must be within $20 of 175. Which of the hotels pictured can they consider? So our first job is to write out the inequality statement. If you remember from chapter 2, our absolute value statements have a general formula of x minus the average or the middle value, and then it used to be equal. Now we're going to have to decide if it's greater than or less than, and then the amount that we can change by. So in this case, the first thing it tells us is that they're spending 4 nights. So if they're spending 4 nights, that's going to be 4 X's. The average, the middle amount that they want to spend is $175. So inside my absolute value bars, I've got 4X minus 175. Because it says within, that's a synonym of between, so that means it's going to be less than or equal to, in AND case, 20. We include the equal to because it could be $20. The answers could be $20. So now that we've written our inequality, we're going to go ahead and split it into case 1 and case 2. So 4X minus 175 is less than $20, and 4X minus 175 is greater than or equal to negative $20. Solving case 1, I'm going to add 175 to both sides of the inequality, which is going to give me 4X is less than or equal to $195. Dividing by 4 on both sides gives me that X is less than or equal to $48.75. If I go through and solve case 2, I add 175 to both sides, and when I do that, I get 4X is greater than or equal to 155. Dividing by 4 on both sides, I get X is greater than or equal to $38.75. So what that means now is our answer has to be between $38.75 and $48.75. So it has to be in between those two values. So if we go back to the original question of which hotels could they consider, the correct answers would be Hotel A and Hotel B. Hotel C is too expensive for their price range. Go ahead and try this one on your own. The first thing I want you to do is just write the absolute value inequality. So when you write your inequality, you get the absolute value of X minus 10,000, that's central cost for the price, and then it's going to be greater than $2,000. The change is going to be more than $2,000. Now go ahead and solve case 1 and case 2. When you solve, you find out that the price is either greater than $12,000 or less than $8,000. The last piece here is writing the absolute value inequalities. Once again, we are using that same general statement, which is going to be X minus the average, so that central number, is either going to be less than or greater than, and then the amount you're changing by. So looking at this graph, we have an OR statement, and we know that OR statements are going to be the greater than case. It's not greater than or equal to because our dots are not filled in. So now our job is to find that average value. If you remember from chapter 2, in order to find average value on a graph, you take your low end point, which in this case is -3, add on your high end point, which in this case is 2. So that's going to give you -1, and then you're going to split that in half to find the average, which is going to give you -0.5. So our average here is at -0.5. Then we have to find the change, or how far it is from the middle to each endpoint. In this case, that change is going to be 2.5 spaces. So that means our final answer for this inequality is going to be X minus -0.5. Now we know from previous lessons that subtracting negatives actually turns into a positive. So it's going to be X plus 0.5 is going to be greater than, because it's an OR statement, and then the amount you can change by is 2.5 on either side. So you find the average, you find the change, and then you put it back into your statement. Go ahead and try this one on your own. So your average is -1. You can go up or down by 5 spaces. So we get a final absolute value inequality of X plus 1, the absolute value, is less than or equal to 5. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.